Okay, so let us begin from here. So um, we have this question here, and we are looking at the limit definition uh, of a function, and then we're looking at the formal limit what definition. So this here requires us to apply what the definition says in order to solve the questions. So now the question reads, the number c there, so the number c, L, and epsilon greater than 0 are given. Then they're saying determine a number, delta, that is greater than 0, such that if I get the absolute value between the difference between that function f of x and the limit, it has to be less than what? Less than epsilon. That is for OX such that I have that the absolute value between the X and the value that I'm approaching, which is C, is what is in between 0 and what and delta. So that is what the definition they've actually given you. That is actually the formal definition of what? Of a limit. So we usually denote, so you denote a limit, say limit as x is approaching a certain value c of a function f of x. This is just equal to what? To L, where L is what? Is that limit. And refresh your mind to say that you would say that a limit exists if I approach, that is, if I am approaching it from the left side and I'm approaching that point from the right side, then if the left-sided and the right-sided limit are equal, then that limit is going to what? It's going to exist. So now, that was grade first year. You must have understood that in grade first year. But now that you're here, we are going to use, that is the definition. And just to refresh you on the definition, what it says is for a given epsilon, so for every given epsilon, that is epsilon greater than 0. So epsilon is just a small value, like very, very small. Yeah, it's small. So what we want to do is that for every given epsilon, we have to find a delta. So there's a specific delta that we have to find, which also has to be greater than 0, such that the difference, that is f of x minus L, has to be less than what? Okay, has to be less than what? Has to be less than epsilon. That is whenever what? Whenever you have that x minus c is what? In between 0 and what? And delta. So now we want to find, our aim is to find this delta. So we'll start first with what? The inequality. So we start from here. So our starting point is here, there, and then we just work algebraically, manipulate all these things that we're able to isolate. What? Isolate something like this. This is the x minus c. We're able to isolate that. Then when we isolate that, then we will be able to what? To find, or to find that what? That delta which we are looking for. Mind you, what this just means is that if this x minus c is less than what? Delta, it's in between 0 and what? Uh, is in between 0 and what? And delta. So this is something that you must take note of. You're saying that delta meaning just has to be what? A positive value, but it has to be small. Right. So let's apply that now. Question 1. So question 1, you have, this is f of x minus 3, then is equal to 2. Is that a question? So if you have a question, feel free to ask. It's a question? Right. So the question, so let's continue. So now what are we saying here? We start from the function. You've been given f of x minus what? 3. Okay, if you're not speaking, kindly mute your mic. Yeah. All right. Thank you. So now we are saying that we start from that function which we've been given. We've been given a c. So a c, they said c is equal to 2 and L is equal to 1. Epsilon is being equal to 0.001. So in short, you have this here, you have that there, and you have c here. that c you have. So the only thing you don't have is what is delta, and we want to find delta. So in short, we are saying that f of x minus what minus the limit L, this is where you start from, is less than what epsilon. So now here I replace that function. So the function is what 2x minus 3, and then this here minus what minus 1, then is what less than, this here is less than what less than epsilon. But what is our epsilon? We have our epsilon, that is just 0.001. so we have this here. And then now what other thing do we have? So from here, or what do we then do? So you can see that what this means here is just 2x minus what 3 minus the 1 there, less than 0.001. And this here, you can just write this, that is, you see that this is gonna be 4 and a 2, so I can factor out a 2, and then I'll remain with x, then minus 2. You agree with me that I've just written the same thing, that is 0.001. So you write it in that way. Now, when you reach here, one thing that you can do, so you see that here, according to the definition of how it is, you have this x minus what, the c there. Now, notice that we can actually obtain such from here. Why? So we're going to isolate here first. I mean how, not why, but we're going to isolate this. That is, 2 is a constant and it's positive, meaning whether you take the modulus of it, it's always going to be positive because 2 is a positive value there. So meaning you can write that as 2 outside, so you move the 2 to the outside, and then you get that remain with the modulus of x minus what? Minus 2. And of course, this is multiplication here. And then less than what? 0.001. Okay, so this is what we have now. So next, we just want to isolate that x minus 2 there. Isolate that x minus 2. Why? Because it's looking like this form here. This form which we have. So here you see there's what? X minus the c. What is our c? Our c is 2 there. So meaning, in short, here when we are to replace, we are going to have what? X minus what? Minus 2. But then in here, we can get that x minus 2. So what do? We just divide by what? By 2 on both sides. So if I divide by 2 on both sides here, what am I gonna have? So they have 0.001. You divide that by 2. So here you remain with x minus 2, modulus of x minus 2 less than, then they have 0.0005. So this is what you obtain, the 0.0005. Now, notice what here, according to our definition, what that is. At 0 is less than x minus c less than what? Delta. So it means that this here, what we found, this has to be less than what? The delta, which implies that this value here, which we've gotten, that value there is our what? Our delta. So delta is just equal to 0.0005. And that's how you get your what? Get your delta, like that. Right. Is there any question before we move on to the next one? Okay, so there's no question. So let's move on to the next one here. Silence means there's no question. Yeah, means we are following and we understand. Hope we're not confused. All right, so you guys feel free to ask because these things here, they confuse sometimes. So yes, now the next one, we follow the same procedure that we did. So we start from the part that is this part where we're saying f of x minus the L, and then minus what? Minus delta there. So of course, we've been given, we have f of x, you have c, you have L, and you have what? You have epsilon. Our only thing we do here is asking us to find what? A delta. So now, notice that where we're starting from, we said f of x minus what? Minus L. But what is our f of x? Our f of x has been given to be, look at that, it's just x minus what? 9. Then over what? X plus 3. Now guys, that you can just factor out. So on top, look at that. You can complete here, it's just the difference of 2 squares. So there, you're going to have this is going to be x minus what? 3. And then you have x plus what? Plus 2. And then, plus what? Plus 3 there. And then you're dividing by what? X plus what? Plus 3. X plus 3 there. So meaning this one and this one, they can cancel out. And then you just have f of x f of x being what? X minus 3. So that's what you remain with f of x, like that. Simple like that. So you get it like that. Now, so when you get it there, you replace here. You're saying this is going to be, that is x minus what? 3, then minus what? Our L. What is our L? Now, our L is there. Our L is just what? Here. I mean, our L is here, negative 6. So there I put negative 6 there. And then modulus, then less than, my epsilon, I have it's there. It's just 0.005. Small value there. Okay. Then now here you're going to have that this is x. So here you multiply, that's going to give you a positive, then minus the 3. There you're going to get that this is plus 3. And then you're saying this is less than 0.005. So we get to this point. Again, we want to isolate. That is, notice from the question that we have, this point here, where we're saying that it's in between 0, that this modulus, that is x minus c, is in between 0 and what? And 0 and delta. So now here, if you replace to what has been given, what is our c? Our c there is just negative 3, like that, and then less than delta. So here you have that this will be x plus 3, then it's less than what? Delta. Oh, now when I look at this side here, what I have, if I isolate what I have here, so this is just the same as writing x minus what? 3, like that, and this here is less than 0.005. So now your c is exactly what you have there, and exactly what we just shown here. So what does that mean? And this is less than what? Delta. So this must imply that that part there, which is there, is just what? Is just delta. So meaning delta, in short, is just equal to 0.005. Okay, so this is how you're what? How you're going to do this one here. Right, so now let's make progress to doing what? The next one. Highway na the limit zone. Okay, so now next, so we want to follow the same kind of one procedure, but now this is where things become amazing. They become interesting on this one. Yeah, this is where mathematics now begins to make sense. Right, so here, what are we going to do? You have a function, so it's f of, that's 1, like 1 over x, and then you have c equal to 2, and then l equal to half, and then you have 0.002, that is your epsilon. So just replace f of x, you have 1 over x, minus your l is just there, 1 over 2, and this is less than 0.002, which is your what? Your epsilon. Now from here, we're gonna work. So here, make this into a single fraction. And this just gives you what? 2 minus x over what? Over 2x. Like this. And then this is less than 0.002, like that. And then now here, this here just implies that modulus, according to those rules you guys you learned in your grade first year. So you can just say that this is 2x, like that, and then you close it there, and then you what? Say 2x down there. So 2x minus 1 on top, and then 2x there, then less than 0.002. So you can write it like this. And then now, notice that I can actually factor out a negative there, here on top. And if I factor out a negative, I get negative there, and then that will be x, then minus 2, like that. I close, and then that is over 2x, and then I close, then I say this is less than 0.002. So this is what I get here. Okay, and then now, after doing this, you know that that negative is just going to go, such that you have x, because it's -1. Modulus of a negative number, it's going to give you a positive value. So you just remain with what? With x here minus 2, then over here you say down 2x, like that, then less than 0.002. Okay, so now we at a good pace here. So now we should remember something here. So from the question, we can get that x minus the c. Now, minus our c here, our c is 2. So that will be 2 there. So you see from the question, our c is 2. And then this has to be less than delta. Now, we need to manipulate this, that we're able to get that. Now, the problem is what we have in the denominator, because if we didn't have this here, we could have just concluded that that's our delta. But the problem is what we have down there. So we need to work on what we have down here. Now notice that 2 being a constant, it's not going to change. It's always going to be 2. So I can write this also as saying x minus 2, then over, I remove the 2 out, and then I remain with what? With x. So now this simplifies my work like that. Because 2 is not going to change, but there, of course, x values, you're going to put different values of what? Of x there. Can be negative, positive, whatever values you're going to you're going to put. But because of the modulus, you're going to get a positive value out of it. But now, back to what we have in the denominator. So now we want to like get rid of that. So now we have to bound it. So we have to bound this which we have the modulus of x. So now how do we bound this? So when it comes to bounding, what you do is you have to make an initial guess. So make an initial guess, usually we just say say your delta is just 1, because 1 is also a small value, not that small, but it's small, and it's okay, and it works well. So we just choose what? Our delta to be what? To be 1. As I said, you guess delta to be 1. Don't guess delta to be any other value, just guess it to be 1. So delta, when we say guess our delta to be what? To be 1. Now, what are we interested in? So when you're bounding, we are bounding what is down here. We're bounding that that modulus of x is what we're bounding. But you do not get the modulus of x when bounding. You get what you have in the numerator in this case. So you get the point that you already have. That is the this here, which is x minus what? Minus the 2. And then you say this x minus 2, because you've guessed your delta to be what? To be 1. So this will be less than what? Less than 1. Then from here, by definition of what this modulus is, means just negative 1 less than, then here x minus 2, then less than what? Less than 1. By definition, that's what that is. And then if you add here, add a positive 2 on each side add a what? Add a positive 2. So you're going to get that this here will give you 1. There you just get x, because positive 2 plus this negative 2 gives you 0, and you just remain with x. That side you get what? You get 3. So you're going to get this 3 here. Now this, what does this help us? This helps us to check the lower number here. And that lower number is what we're going to what we're going to use here. So we're going to use that that lower number here. So what are we going to say about this lower number here? So when we get that lower number, you're going to replace it in your in your function. So now you're going to say that this number here, when I replace it there, I'm just going to get what? Modulus of negative what? Negative 1, which is just going to be positive. And then you just have that this here. Now notice that here, if we get values, so you pick. So the reason why we are picking this here, you want to just know how to bound this. So now here you get the lower value, especially when what you're bounding is what is down. What you're bounding is down here. So you get that lower value. And then what you're going to say, since this x here, you see that x is greater than 1, because you've gotten x1, meaning the values of x that you are going to be getting, you only consider those that are greater than 1. And then now here, what you do is, it means that the modulus, now from 1, I'm going to say that I can get, saying the modulus here would imply, if I get a modulus there of 1, modulus of 1, the other side will still be 1. Then I can write this here. Notice if I reverse it to say modulus of x is going just to be less than what? Than 1, like that. Did I write it well? No. So this here is going to be, so I mean here then now on both sides, notice that when you divide by this modulus of x, you're going to have 1 there greater than 1 over what? Modulus of x, yes. And then now you write the other way around, which is 1 over modulus of x, then less than what? Less than 1. So this here is how it's what? It's being bounded. So now, this is what just this here, what we had written, what means. But then, what is down here? From what is down, right? What is down, you can see that you are going to, you can multiply. So if I multiply here 2, multiply 2 there, and multiply another 2 there, you're just going to get what you have in the denominator. So you're just going to get, and that is because x is greater than 1. But so here, meaning you're going to get what? Positive values here. So that means if I add the 2 which is down there, this side and that side, I just get that 2 modulus of what? X is greater than what? Greater than 2. So I can get this here. And that is because I found that this is in between 1 and what? And 3, like that. So I'm going to use this fact now. So now this here has its what? Has its minimum value. So remember the minimum value which we said, which is that 1. So you just bring the minimum value there and what? Replace. So 1 there, and this just gives you what? This will give you what? A 2. So we're going to use, meaning there where there is modulus of 2, you can just replace what? Replace with a 2, in short. So meaning this x minus the modulus of x there, and then the 2x there can be bounded by what? By 2, in short. So now I raise here. From there, if you found out that fact, so here where we had ended, meaning you can just say modulus of x minus 2, and then that there is just going to be less than 0.002, and then multiplied by what? 2 modulus of what? Of x, because you can cross multiply there. And this here is just going to be x minus 2 less than 0.002. And then there, you're going to say this part here, replace with what? The 2 there. And then you have x minus what? 2 there is going to be less than 0.004. So now, according to what we have, meaning the delta, we say delta is small. So meaning, according to analysis, at first we had chosen delta to be what? To be 1. And that's what helped us to find that this relationship here. So now we chose delta to be 1. So meaning we actually have 2 values of what? Of delta. So we say delta is going to just be the what? The minimum. So delta is going to be equal to, that is the minimum between the what? The 1 and this one which we found. Because this here now, you have the x minus 2 here, less than, which is less than here what we found, and then less than the delta. So this would mean that this here is your delta, less than the 0.004. So you choose what is less here. So between 1 and the answer which you found, which one is small? The one which you found is what? This is the 0.004 is the small one. So this is what is going to be your what? Your delta. And that's how you find this one. So yeah, amazing. Okay, do we have any questions? Yes, somebody raised their hand. Please, you can.
Yes, sir. My question was, if I do not want to go through this process where you said you pick one value, for example, the smallest value, in this case, you have advised us to be using 1 to represent the value of x on the denominator. Is it okay that instead of me showing all these x minus 1 modulus less than delta, if I just go direct to what you have done here, where you say the modulus of x minus 2 less than 0.04, is it okay if I can go that way?
If you go to this part here, you write just this part.
Yes.
Okay. So, I don't think they can penalize you as long as you make the statement that, first of all, now the thing is, because of what is down here, that's why we're bounding. You find it in the next question. It's going to be very useful in the next question that we're going to do here. That when you bound, it actually helps you a lot. in the next question here, you see it. But then if you just state that, if you state the fact that we bound, you just write a statement to say bound the denominator, and then that is using what? Value 1, and then you go direct to here, then it's going to be what? Okay, and then you can replace. So the reason why I had to go through this is to show you how actually we bound and where that one is actually coming from. Like you make an assumption, or you make that guess to say, okay, it's going to be this here, and then you choose between the two. So that's the way that you would go. Yeah. So I don't know if
Right.
it's
Thank you.
as long
Thank
as you
you
make
very
that.
much.
Sure. Okay. Right. So now let's go on to doing this other one here. Okay. So now, when we look at this one, you have this, and you have, again, the whole things have been given. Also, another interesting question which we can learn from here. So this one here, you have, so you start again. So f of x has been given as what? That is 3 over what? X minus x plus what? 3. And then you have minus, your L is just 3 over what? 3 over 4. And then this is less than, so it's less than what? 0. Okay, so 0.001. Actually, 3 zeros here. Okay, 0.001. And then now, what are we saying here? So you can here you can make this into a single fraction, and you see that down there it's just 4x plus 3, and then close there. You're just gonna have 12 here, and then minus 4, then multiplied by that there just gives us, you have 3 here, in short, multiplying by the x plus what? 3. Okay, then less than 0.0001. And then here, make this into a single what? Like work this out properly, clean it up. In short, so here you have a 3x, negative 3x, there you have a 9, negative 9. So negative 9 can subtract with the 3, you get 3. So 3 minus 3x here over 4, then you have what? X plus 3. So now notice that there from the top, you can factor out a what? A 3. So if I factor out a 3 there, I'm just going to have 3. Then there you have what? You have, you can actually factor out a negative what? A negative 3, right? So negative 3 here, and then you have, that is going to be x minus what? Minus 1. Then you close, then there you have what? 4, then x plus what? Plus 3, and then less than 0.0001. So you get this here. Now, from here, you can remove. So this negative here on top is going to be a positive. Yeah, when you move it out of there. So you get just there like that, and then 4. Then you have modulus there, x minus 1. Then close, then modulus of x plus what? Plus 3. Then less than 0.0001. This is what you are going to get here. And taking this the other side, that I remain with, now notice that here you said your C is 1. So here at this part, this part here where we keep on saying, so our x is just going to be x minus our C is 1. So in short, we are looking for a C minus 1. So let's isolate that C minus 1. So if we isolate that C minus 1, we have x minus 1, and then this is going to be less than what? So take this the other side. So these two here are just gonna swap. That is gonna be 4 over 3 now. So 4 over 3, and then you're multiplying, that is on top there by x plus what? Plus the 3, like that. Okay, so this is what you're going to have here. Now, again, we have to bound that other side. And this time around, it's what? It's on top, like that. The other one was what? Was down. So we bound it now. So now, how are we going to bound this? Again, as I said, you make that initial guess. The guess is that, oh, our epsilon is just equal to what? To 1. I mean, our delta is equal to 1. So I guess the initial delta to be 1. Then after I guess that initial delta, I start from this point here where I know. So you always need to start with a point where you know, that is x. I mean, this part here, which is x minus 1, and then because it's less than delta, and you've guessed delta to be 1. So you say x minus 1, then you say less delta, but that delta is just what? 1 in this case, because you've chosen delta, you've guessed delta to be 1. And then now, by definition, this just implies that it's mean between -1 and then x minus 1, x, and then 1. So now here, notice that this here just gives you what? This is just, if you take 1, if you add 1 on each side, you're just going to get 0 there. Here you get x, and there you get what? 2. So you get these values here. Now, the problem is what? The problem is what we have down. So remember, the problem is this x minus what? Minus 3. And then we want to bound that x minus 3. So meaning from what we have here is we're asking ourselves, since we've noticed that this is like this, can we get that x, this x plus 3? Can we get something like that there? A similar thing? Of course, yes, we can. How? If I add a 3 there on this, on each side, you're going to have that is 3, and that there you're going to get x plus what? Plus the 3, and the other side you get what? You get 5. So here is what you're going to want, which you're going to have. Now, this helps us choose a number. This number now, the purpose, remember, we said that you want the value of your the value of what? The value of your delta to be what? To be small. So you want that value of your delta, or the value of your what? Of your epsilon to be what? To be small. So what are you going to do now here? So here you're going to choose what number is going to make that what? That epsilon small. When I replace it back there, that is, I'm going to replace. So here you choose only the part now. You're saying this is going to be like modulus of 3 less than what? Less than whatever value you're going to choose. Now, between the 3 and the 2 and the 5, I mean, which one is going to make this fraction here to be what? To give us a small value there. Now, when you look at it here, you have 3 over what? You have 4 over 3. So you have a 4 divided by 3, which is like 1.33 something. So now notice if you multiply that by 3, you get a what? You get a smaller value of like 4. And then when you have that same value, that 4 divided by 3, then multiplied by 5, you get a bigger value. So now that bigger value would mean this 0.0 is going to be what? Is going to be big. But then we want to get what? The most smallest value, that is the minimum. You want to get the what? The minimum here. So now, which means what are you going to do here? You're going to pick a value that is less than what? Less than that is this here. We're going to bound it by what? By 3, because the 3 is the small one there. So 3, we use 3, and then you get the 3, and then you replace back in your what? In your equation. So here you're going to have, let me erase this part. Or I should have erased this part. Anyway, yeah. So you're going to have that, replace that there. You're going to have that is going to be a. So now we go back to this equation here. Oh, and I forgot to add the. Remember, there's this other part, which is the 0.00 what? 01, which is there. Yeah, because it's multiplying also by that side. So meaning here you're going to have, that is x minus what? 1, and then less than 4 over what? Over 3, and then you have what there? You just replace with 3, and there you have 0.0001, like that. And this here is going to be, that is x minus 1, and then it's going to be less than what? So this and that divide, and then this here are going to have, that is going to be 0. That's 0.0004. So you get this to be 0.004. And then now here you're going to conclude. Now this is what we have here. So meaning we can say our delta is just the minimum, that is between what? Between 1 and the 0.00004. So this here is what you're going to get. But and then this is your minimum, but here you know that your minimum is just 0.0004, like that. So meaning this here is going to be what? To be your delta. Right. Do we have any questions here? Now, before we just go on to do the next question here, which is still on the limit definitions, I want to show you guys how you can have access to more of our tutorials. So now, where here you just go to your web browser and you can type discrete learning. Go to there, discretelearning.com. So now when you visit discretelearning.com here, this is our website. This is where we post all the full solutions that you might want. The assignments are posted here and all that. So now you can go here, say Discrete Learning Institute. If you don't have an account, do register for an account here. It's very easy. And then you subscribe to your desired course. So you see that here you can click subscribe for course. Then now it will bring you the amount here according to what course you want to subscribe. You see there, analytical geometry and calculus is here. Then you can subscribe for that course, and then you can you can proceed there and make payment for that course, that you're able to access all those solutions that you might want. Now, apart from that, now let me show you the content that you have access to. So that is when you go, we say that is and of course, all other math courses, you can see they're here. So analytical geometry and calculus. So here you have topics, you have summarized notes, and you have tutorial sheets, and you have what. So let's start with the tutorial sheets here. So when you see these tutorial sheets, yeah, so you can also check these like 2025, 2026. Actually, the tutorial sheets 2025, 2026, that's far. They have not changed. They're just the same things. So you see me, if I've not updated it here, just check for it in the 2025. It's actually the same the same thing. Like the lecturer has not changed those tutorial sheets here. But then you can go here, you see like assignment 1. It was here. Assignment 1 was solved. You just have access to it. Just open there, and then you can you can access those solutions here to to assignment 1. And that is there where you have the assignment. You have the question there placed, and then you have the solutions to the assignment that are put here. They are well solved, and you can you can easily follow through these this assignment. Not only that, you do not have only access to that. So we've talked about the tutorial sheet. There are video solutions and written solutions here. But now, apart from that, I want to show you also how to. So this is on the tutorial sheets, but you can also access You can also access our past papers. So now you're preparing this time. I'm sure you guys are preparing for quizzes like quiz 1. Maybe you've not yet written quiz 1, you've not yet written you've not yet written test 1, but it's good to start early with preparations. So here you see video solutions here. So when you go in these video solutions, you're going to find past papers. They're here. So you have these questions solved 2024 here, exam past paper, and then you see like last year's paper, it's here. The first topic, you guys, quiz 1, you probably are going to be assessed on conic sections. So watch this video here on conic section and transformation. Watch this video here on polar equation of Of conic sections. You're looking at limit, definition, proof. This here, you have the limit definition of of a proof. And this here, you can't access them on on the YouTube channel, but you can find them on on the website, the limit definition, showing that showing the limit of of a given function. All these here, you find convergence here of the ratio test. You can find them all on these all topics that you're looking at now, the mean value theorem. All these the past papers have been so even the next topics that are to come, you can find them here on on the past paper solutions that are here. So this is how you access our website. Now let's continue and do that next question which we have for today. So not to take much of your assist, but then we can do this question here, and then we finish up on this one. Right, so now this question, yes, still again kind of lingering on the thought or applying applying the definition of the limit. So they're saying to show that the limit as you approach x of of c, that is of f of x, is equal to this. So then they're saying directly using the formal definition by by finding the corresponding delta to every to every epsilon. So they want us to find that delta. So now the corresponding delta here, you see how we are going to what we are going to find, and we're using the formal definition. So now, unlike the one which they had given you before, where you had a specific what was given, like a specific, you had a specific epsilon, like which was given. Epsilon here has not been given. It's just been stated that epsilon is greater than 0. So now, what are you going to do here in order to access that? So in order, I mean, to find that. So you use the definition, and then you must recall from the definition that we said that a limit. So limit, we said a limit that is x as it approaches c of what of the function what f of x. This the limit is just what L. And then using the formal definition, that's the epsilon delta what definition, which is just saying that for every value, that is for every epsilon greater than 0, there's a corresponding what? Corresponding delta greater than what? Greater than 0. And then you're saying this delta is in between, that is the modulus of x less than c is less than what? The delta. So this here you should remember. And then that is, that follows from what? From f of x minus what? Minus L being less than what? Less than delta. So this here is what you're going to what? What you're going to use. So you use this here. So now, what do we do now? From here, we just follow up even as. So first one, there you just say that would be 3x minus 5, like that, and then less than, that is minus, and then what is your what? You have your L there to be what? To be negative 2. And then you close. Now, this here I was saying it's less than what? Less than epsilon, as you can see there. Now notice one thing that you must remember is that what do you want to get from here? So you have the x minus the c. Now your c here is 1, so minus what? Minus a 1. So you have to have this part here is what you want to get from there. So now from here, let's get that. So this is going to be 3x. Here you have this will be positive 2, but positive 2 there, you just have a minus what? Minus 3 here remain. Less than what? Epsilon. Then you can factor out that 3 there. 3, and then you have x minus 1, like that, and then less than what? Epsilon. Then the 3 outside, then you just gives you 3 less than x minus 1, then less than what? Epsilon, like that. Now you have this part. Now you've seen that you have the part which is what? Less than the x minus what? 1. But this here further on, you can just say this is just x minus 1 less than what? Epsilon over what? Over 3 there. Now from here, you've seen that what is that corresponding delta? So meaning the delta from what we have here, you're just choosing that your delta is just what? Epsilon over what? Over 3. As you can see that this is x minus L. But here what we said, according to this here, x minus c less than delta, which is here, we replaced our c. Our c is 1, is there. Replace it there, you get this, and this is less than delta. So this here makes sense that we're going to choose that delta is epsilon over what? Over 3. Now, a way to prove is that when you put it back here, you're going to have x minus 1, that is less than, and then your delta is what? Delta is, so here you have delta, like that. Now, you're going to, what you're going to replace here is, you've said that your epsilon, I mean your delta, you say that your delta is what? Is just this epsilon over what? Over 3. Okay, somebody is writing on my screen. Okay, so all right, thank you. So now let's continue here from what we were saying. So now what I was saying is this. So from here, this part here, as you can see, you have in short, what I mean is this part here, when you reach this part, you got that this is 3 multiplied by what? X minus 1. Now, what is this? This here being less than delta just means that this part is delta. So that just means that that part is what? Is delta. So meaning I can say that is x minus 1 less than what? 3 delta. And then when you place your delta, your chosen value of delta, that is just what? Epsilon over 3. Here you divide there and you're just going to get what? Epsilon. So this is how you just simply what? Simply showing. And then you end and just say hence what? Hence shown. So hence shown, like that. Okay, so it's easy when you just find your delta there, your delta, or what you choose to be your what? Your delta. All right, so this is how you would what? You would go about this question. Let's do the next one. Okay, so let me bring back. Okay, yes, there's those things here very important that we should remember. Okay, next now we have that. So we start again. So you start from this part, the same f of x modulus less than what? Your epsilon. So now for our question B, it's this one here. So that is x squared minus 4, then over what? Over x plus 2. And then that there minus your L. Your L is what? Is that your L is 4. Now, your L is negative 4. Wow, it's negative 4. How didn't I notice that? So it's negative 4, meaning here I replace the what? Negative, and this will be positive, like that. So you're going to get positive there. And then here, what are we saying? So we are saying that this here is going to be what? Less than what? Less than epsilon, like that. Now, notice that here you can write this here, we could factor this out as difference of two squares is just going to give us x plus 2, and then you have what? X minus 2 there. Then you have x what? Plus 2 there. So this and that cancel, and you just remain with x minus what? Minus 2. So you have x minus 2 and then plus what? 4 there, and then it's less than what? Epsilon. So you're going to have this here. And of course, so now after getting this here, we can now here and that you're just going to have that this is going to be x, and that will give you positive 2, and then less than what? Less than 3. This is what you're going to what you're going to get here. And then now from here, what are we going to find here? So now directly I want you to notice this, like what directly this would give us. So here, if we get when you look at the part where we have to check, which is this part, so here it's going to be x, then minus our c is just negative 2, which gives us a negative 2 there, like that, and then you close there, less than what? Less than your delta. So this is what you're going to what you're going to get. So here, what does this mean? So here, if I write it like that, it's less than what? Less than epsilon. So what does this then mean? So this just means that your epsilon is what? Is equal to the delta. So that's what you have here. Your epsilon is equal to the what? To the delta, like that. And then, okay, so your epsilon is equal to the what? Is equal to the delta, which is that one there. And actually, there's nothing even more to prove here. Just say hence shown, like that. Because here on your delta, if you replace epsilon, you just get epsilon. So there's nothing to change here about it. All right, so that's how you do this one. I think question B was much easier. I just needed to factorize. Right, so next we have this one here, and again, all those things have been given. So we have 1 over what? X plus 3, and then minus your L is just 1, and then they are less than what? Epsilon. So you make this into a single fraction, which is just going to be over x plus what? Plus 3, and then there you have, this is 1 minus, this will give you minus what? X, then minus what? Minus 3. And less than what? Delta, I mean less than epsilon there. And this here just gives us, can actually factor out. So okay, to give us negative x, then minus 2 there, and then you have x plus what? Plus 3, and this is less than what? Epsilon. Now this here, what is it going to give you? So you're going to have that, factor out that negative on top, you just remain with what? The x plus what? Plus x plus 2. And this is over what? X plus what? 3, like that. So this is what you're going to get. And then notice that you can actually write them separately, because it's epsilon, yeah, it's the modulus you're dealing with. So that's x plus what? 2. Then over there, x plus what? Plus 3, like that. And then less than what? Epsilon. So this is what you're going to what you're going to get. Now, remember the concept we looked at earlier, bounding. You have to bound what we have in the what? In the bottom there. So now, here, I said you usually choose, but then it did not mean it's always the case, especially in a case where you have a linear function, like you have x plus 3 here and then you have x plus 2, like both they are in the numerator and in the denominator. In this case, you usually what? You usually bound or you choose your delta 1 to be what? 1 over 2. So we are trying to bound what we have in the denominator there, that is the x plus 3. But we are going to choose our delta to be what? To be 1 over 2. So now, but then when I'm bounding, what am I doing? I'm just saying, so here, this part, which is the x minus what? The c, which I have. So now, in my case, the c, remember here now, oh, let's erase this one. It's going to be what? Our x minus our c, there is negative 2, and that is less than what? Delta. So now, I'm going to say that x minus c like that, and then less than my delta is, I've chosen to be what? To be half. So you choose delta to be half like that, and I've given the condition where you usually choose delta to be what? To be half. Okay, then now what does this then imply for us? Now this here is just, of course, the positive version, which is just x plus 2 less than what? Half like that. So now this here by definition is just this side negative 2, then you have x plus what? Plus 2, and then there you have what? Half. And then now, what do we want to get? We want to get a 3 there. We want to what? We want to get a 3. So now, how do we get a 3? By adding a 1. So you add a 1 here. So it will be plus what? Plus 1. And there plus 1. There plus what? 1. Which is going to just give you, this side you get, this is going to be half, less than x, then plus what? 3, less than, there you add to be 3 over what? 3 over 2. So you're going to get here. Now, since you see that in the denominator there, it's modulus of x plus 3, that is always going to be positive. And if it's always going to be positive, for whatever value we're going to put here, like if it's always going to be positive, then it means that this modulus here of x plus what? 3 has to be greater than what? Greater than the half. Has to be greater than what? Greater than half. Now, what does this then mean for us? So this here, and because we are bounding what is down. Now, this is where the difference is. So when you're bounding what is up, you use the value which is what? You use the value which is, so from this here, from this point, remember this point here, we are using this only to find a bound. So now, if you're bounding what is down, you're going to use what? A value which is bigger. Then when you're bounding what is on top, that is in the numerator, use the one which is smaller. Okay, so now here it means that we can actually bound this now using the what? We say x plus what? Plus 3 is going to be less than the bigger one, which is 3 over 2. So the person that was saying go directly, this is, I think now you've seen why it's important for us to do the bounding here. So that is when we're bounding for what is what? Down. Because you know when you have a bigger thing here on top, I mean down, when you have a bigger thing, it means your fraction is going to be what? Smaller. And then you have what? You have a smaller number there like that. Okay, so this is what you're going to what you're going to do here. And then now bringing it back. So we've found that our bound is just 3 over what? 3 over 2. Let me continue from here. So we found that to be like that. Now bringing it back here where we were. So what does this then going towards to imply? So that I can write as x plus 2 like that to be less than, cross multiply, then you just get that that is going to be what? Epsilon. Then you have x plus what? Plus 3 like that. And then you have x plus 2 here to be less than. Now here you've bounded using what? You bounded the 3 using 3 there, 3 over 2. So this means that this will be just what? This will be 3 over what? Over 2 multiplied by that what? Epsilon. This is what you're going to get. Now, what is your delta? Corresponding delta is just going to be our delta, which makes this successful, is the minimum between what? The half and what you got, which is the 3 over what? Over 2 epsilon. And of course, this is just going to depend what? Depend on the value of epsilon which you're going to get. But epsilon is usually small, so it can be this one or that one, depending on what value of epsilon you're going to what? You're going to get. But you end here and you just say hence what? Hence shown, like that. Okay, so we have this. So let's now do the last question there. After we've established all this, let's do the last question now. Okay, so the last one, you have that function there. So that's what you're going to start from. you say that is x minus 1 over what? X plus 1. And then you say that to be minus your L. But your L is just there, which is going to be what? Positive. That would be plus what? Plus 1. And then you close. Yes, somebody raised their hand.
So my question is, I have observed most of the time, after you equate that equation to epsilon naught, you usually go back and use that one for delta, where you use the C, then where you use the L is that one which is used for epsilon. Now, is it mandatory that always when you want to find the value of epsilon, for example, you are given the f of x, which is a fraction, you have to go back and use that one for delta? That's my question.
All right. So now I think you should observe why we are using this delta, this part of the delta, of this part of the equation where we are coming from here. It's because the condition is that for every epsilon greater than 0, where we are saying that the modulus of f of x less than L is less than epsilon. This is true whenever there exists a delta greater than 0, whenever this condition here is satisfied. That's why we're going back to this condition. So this condition has to be satisfied. So you have to check that what have been given there, my x and my c, can I get that part from there? And then I go back to here. And then if we've chosen a specific delta, meaning you have to replace this delta and then what? Work it out that you're able to get the other corresponding value of what? Of another delta which you might what? Might have. That's why we keep on going back there. So this condition, whenever this condition has to be there. That's why we are going back to this condition.
All right, thank you.
All right. So now, after we've established this, now we can say this here we can just make into a single fraction. Also here it's less than what? Less than epsilon. Then make this now into a single fraction. You're going to have that is x, then minus 1, and then plus this here that is just going to be plus what? X plus 1, like that. And then this here is going to be, did I do that right? Yes, right. So this is x and then, yeah, x then 1, right. Okay, yeah, that's okay. And then over what? Over x, and then you have a what? Plus 1, and then less than what? Less than epsilon there. So now what is this then going to be? So this here is going to be, that is modulus. Here on top, you're going to have 2, and there you get what? 0. So you get 2x. That will be 2x, and then over what? X plus 1. This is less than what? Epsilon. Now here we are bounding what we have on top. So you're bounding what you have what on top there. So this is going to be modulus of what? Of so I can move the 2 there. So that I have just modulus of x, then I have modulus of x plus what? Plus 1, like that, closed, and it's less than what? Less than epsilon. So now we have to bound the so now look at, okay, so again here, this is where you now go back. So you check now that your x minus, what is your c? Your c in this case is 0. So your c is that one, 0. Here it's 0, like that. So meaning in short, you're going to have x there less than what? Less than your delta, like that. This is what you're expecting on top. So again, we're not bounding actually what is on top, we're bounding what is down. Yeah, bounding what is down. And we said if you're usually bounding what is down, you want to bound this x plus 1. Usually bound using what? You choose, so you say choose delta 1 to just be equal to what? To half, if you're bounding in such a case. So now here, this means that we are going to say what? From here, which we found this part here, we can just say that this x to be less than, what's our delta? Half. But by definition, what of the modulus, this is just between negative half and then x there less than what? Less than half. Okay, so now from there, what are we going to get? Now we want to get this x plus 1 from there. So I need to add a what? Plus 1 on each side. There, there, and there. So there, when I add the plus 1, what do I get? I get half, then less than x plus what? Plus 1, and then less than what? 3 over 2. So this is what I'm going to what I'm going to get here. So now remember, we are bounding what we have down there, and then what do we want there? What value is going to make that to be what? To be, so we said you bound it in such a way. Remember, you want to bound it in such a way that you're going to have a what to have. So now, okay, let me multiply here such that you see it out. Here, where we had ended. So we ended on 2x here like that. So there I can cross multiply such that I have 3. Then I have what? X plus what? Plus 1 there like that. And then what else? I can have a 2 now, divide by that 2, such that I have x less than epsilon. Then you have what? X plus 1. Then over what? Over 2 there. Now, notice one thing here that we had said, which is kind of very, very, very important to take note. That is, we had said that when you're bounding something that is, in this case here, we are bounding something that is down there. So if you're bounding something which is down there, you want to pick a value that is going to be what? To be large. So it means between these values which you found, you're going to pick what? The value which is large. So this is going to be x, and then there you're going to replace that is that over that multiplied by the larger one is 3 over 2. 3 over 2. Then you multiply here, you just get that less than, and then here you get you're just going to get 3 over what? 4, and then what? Your epsilon. So meaning that your delta, since this part x minus what is what we have here, x less than delta, it means that our delta is just going to be, remember we chose first delta, we chose delta to be half. So the minimum between what? Half, and then the what? 3 over 4 epsilon like that. So it's just a coincidence that we found 3 over 4 even here. It's not usually the case. Right. So this is how you'd solve these questions using the formal what? Formal proof of the limits. Unless there's any question, from anybody else, but this is what we do. Now, I know that sometimes you'd want to find these not only on the website, but I've said, guys, do subscribe on the website. If you want to get those past paper solutions, you don't find them anywhere. Those others, some of these solutions are never posted anywhere else apart from what? From the YouTube channel. Now here, you can also find these videos. That is, when you go search here, just search Math with Marius. So here, search Math with Marius. You're going to find these are helpful what? Videos. So this is going to come here, and then you can go. And then now, just scroll down. So you see this here is just like math, deals with math videos. So you scroll and you can see the further topics that you're going to do in the near future. Actually here, example here, you have this here, this video, it's saying evaluating the limit, that is x squared ln. Watch this video. There's this here on the rational root test, proving here you have does it converge, showing that this limit here is equal to e. These are the questions and that you're looking at even on what? On limits. So you make sure you just do those, you're able to what? To access those here on the what? On the YouTube channel. So these are the free videos, some of the free videos that you can want. You can access them. Further topics, all these here, 2100 videos. There are 2100 videos. They are calculus 2 videos. These vector analysis questions here, this is the next question you'll be looking at. Rolle's theorem, mean value theorem, convergence, tutorial sheet 4 here, 20, you see here 2100. You can find those problems there and you can just go through them. And yeah, all those magic substitutions, these are things that are going integration. You do well to have access to this here. So you can just go search for what you want here. You can find videos here for 2100, and also you can also find other videos. So you go to tutor solution. So if you go to tutor solution here, you see here tutor solutions. Apart from those, I know the 2100 videos you're looking for, you can find other what's this material that is here, that is for the other courses that you guys are taking. The 2200, the what here, you have them, they are solved here. So things like here, probability quiz 1 revision, these things are things that you must be looking out for, you must be checking out to find here. You have videos like this showing the skew symmetric orthogonal matrices there. You can find them on the on this channel here. And also you can visit that is discrete learning here. So when you go to discrete learning, this is the main channel which we have. So if you go here, you also find you find the other videos that you can see here. Master probability, anything that you have to know about probability, you can find, guys. You can find them there. Basics of matrices, everything you need to know, those concepts there. You can find them there. They are already there waiting for you. Then now, those that want to subscribe or want to I've already showed you how to subscribe, but you can also watch our video on how to pay and how to create an account there. Then you can be able to do that. If you want to do revisions on the parabola, you can see there's a video here, parabola, to help you solve these questions, past paper questions on the tutorial sheet questions that you can watch and prepare for your quiz 1. Okay, so this has been Tutor Marius, and I'll see you in the next one.